Well, thanks for joining us for another episode of the news.
Be sure and check us out next week. Same time, same channel.
Be sure to hit the little bell at the bottom. That'll be good. See you guys.
See ya. That was a good episode.
That was a good episode. I don't understand. Hopefully it recorded correctly.
Yeah, I'm just going to copy this to the network drive. You go grab the Star Trek action figures, and we'll get this party started.
Yeah, that'll be great.
All right, excellent. I'm going to be Troy this time. All right? Let's agree to that right now.
That's fine.
Okay.
As long as can I put Worf's head on Data's body, like transport
Again?
accident? I mean, it's a lot of fun.
Wait. The network drive is full. How could it be full?
What? Oh, what's going on with this?
I thought you were going to add storage.
I did. I added a terabyte.
When?
3 days ago.
How do we use up that much storage in that amount of time?
Let's figure it out.
It's a bunch of encrypted files in Krista's folder.
We've talked about this with her before.
You know, ever since we started the Level 1 thing, it used to be just us and her friends and some of the Twitch viewers. But now,
most of the Twitch viewers.
Now it's YouTube commenters, it's other YouTubers. The stalking, it's gotten out of control.
It really, she's really, really good at it. It's really scary. I mean, this is terabytes and terabytes of data.
So, I've tried to talk to her about it. She just hisses at me and tries to claw my eyes.
I haven't seen her in a while. You think she's in her lair?
Yeah. She spends most of her time in there. But I don't know what we're going to do about this. I mean, how can we solve this problem? If she's using a terabyte every week, every 3 days.
Well, you know what? I've never really had good luck confronting her with that. Why don't we just build the storage array to end all storage arrays and just call it a day?
It's going to have to be like 100 terabytes.
Well, we could probably do 170.
170? That should buy us like a month, maybe more.
Well, it's going to have to buy us at least 6 months because I don't think we're going to have the Patreon money to get something larger for a long time. Maybe with compression?
We might as well do it.
Let's do it. Let's build a storage array. Well, if you don't get bored and run away, we're going to show you sort of the mindset of a system architect. We came at this video a bunch of different ways, but ultimately thought that, system architecture, what does it mean to be a system architect? Because from a career, you guys may be interested in that. And approaching our video storage solution for Level 1, we kind of were like, yeah, this is kind of a system architecture problem. Maybe we could give people a quick overview. This could also be a jumping off point for a whole bunch of different subjects, not just for, the Level 1 channel, but also for the Linux channel, maybe even the Enterprise channel, because this is all enterprise grade hardware that we're talking about for this stuff. Krista's data hoarding problem aside, dealing with the problem in typical nerd fashion, sort of passive aggressively, we'll deal with that by adding more storage rather than confronting the problem head on. But it's probably fine. We're all data hoarders, I guess. If you can stick with me, you can sort of run through the mindset, the thought process of a system architect. And so we picked up some stuff from Surplus. Well, actually, this is from a different project, but we picked up some stuff from Surplus. And, data storage is a real problem because we don't really want to spend a lot of money, but we want something that's good. So what's the biggest bang for our buck? And like a lot of things, it's probably getting some used enterprise gear rather than buying a whole bunch of new stuff. And so what does it really mean for video storage? It's like, well, let's turn it around and let's talk about it in terms of system architecture. If I were a system architect and I were brought in to look at this, and I wanted to spend as little money as possible, but end up with a reasonable result, I'm going to have to look at what the requirements are. So the real requirements are good storage of video, a lot of video potentially, because even just recording this, this project is going to be 50 gigabytes probably of video. By the time everything is said and done, even just to edit it down to a 10-minute video. Hey, there may be more videos in store, who knows, for the different kinds of projects that we do. There are other kinds of projects that we do. We do stuff with Linux, we do stuff with virtual machines, we do stuff with other types of storage. There's only going to be 5 people hitting the system at once. It's an enterprise system with only 5 people. That sounds like a developer organization or something crazy like that. We want it to be as fast as possible. We want people using this storage to feel like that they're using storage on their local computer. We want whatever operations are running on the storage to feel as fast as possible, as fast as it possibly can, without also spending an insane amount of money. And so what are some of the low-hanging fruit options that go through my head as a system architect? you know, and when I've got my system architect hat on for doing those kinds of things. Like, well, a SAN, storage area network, is one of the first things that pop into my head. There's probably some of you guys out there in the enterprise where your companies, places you work for, are still running these 6510s, or maybe you have this as an equal logic unit. It's got 48 physical hard drive slots in it. It will support SSDs, 15,000 RPM SCSI hard drives, the whole 9 yards. It's got 40 gigabits of connectivity. It's got 4 10 gigabit interfaces in 2 redundant controllers. This thing's a beast. It's completely nuts. The first thing that you have to learn as a system architect is where the bodies are buried, what the lies are. And the first lie is that there's no such thing as hardware RAID. And what I mean by that is that somewhere there's a computer doing software for your RAID, and it is important to understand what exactly that software is written to do. And so it's like, wait, this is a hardware RAID controller. Yes. And we got some lovely B-roll of this hardware RAID controller. This is an LSI controller. It's older, but you know, this is quote unquote a hardware RAID controller. But it's not really, I mean, what do we mean by that? It's a computer on a card. There's a computer, a processor on this PCI Express card with some RAM and a battery backup unit, so this computer on this card will keep running even when the host computer that's connected to through PCI Express is not supplying power anymore. And what the software on this computer does is make sure that everything that was written to RAM on this card makes it to the physical disks the next time they're turned on. So if there's an unexpected power outage or a crash or something like that, and this RAID controller is cut off from its disks, whatever it had not written to disk will hang behind in memory on this card because of this battery, and whenever the disks get turned back on, it will be written to disk. Same with this guy. This guy has a computer in it, and it has a battery. Each computer has a battery, actually, and it's got 2 gigabytes of RAM. I mean, this is DIMM cards. This should look pretty familiar. And this guy has 2 10 gigabit GBIC interfaces and an Ethernet interface, but it's really just a computer on a card, and the enclosure has 2 of them. It's really just the software. Well, now what about these guys? What do they have for a computer? Well, they don't have a computer. They're disk shelves. They're disk shelves that include a port multiplier, which is another important component of the system. I'll come back to that in a minute. But they're really just serial attached SCSI interfaces to a controller. It's like, all right, well, what are we going to use for a computer in that case to manage the data, to manage the array? Glad you asked. We're going to repurpose the Google search appliance, because it's not without a certain sense of irony that we do that, into actually hosting and maintaining and controlling the data. So, okay, what file system are we going to use? We're going to use ZFS. ZFS is probably the file system that they're using on the enterprise. It is an incredibly advanced file system. It does have a ridiculous amount of overhead. You lose performance, like from the raw hardware. There is a performance penalty associated with ZFS because it does so much stuff. But system architect, this is going to be our primary storage. We need some data integrity checking. We need some control over that. The penalty doesn't really bother me that much. I'm thinking in the back of my head, you know, what are the options for interface speed? 10 gigabit, dual 10 gigabit Ethernet, 40 gigabit Ethernet maybe, and that's pretty much it. We could do, you know, Thunderbolt as an option. I took a look at an Acusys storage device that had 4 Thunderbolt ports. That is a really clever, really low-cost option to deliver a lot of bandwidth to a relatively small number of editing workstations. And honestly, that wouldn't be a terrible solution in this scenario because of the bandwidth. The software support is the only thing that's really lacking in that solution. With this, you know, we're talking about 10 gigabit Ethernet, a little over a gigabyte per second in real world performance. That's going to be faster than any SATA SSD, but it's not going to be quite as fast as a high performance NVMe type SSD. So faster than SATA, but slower than NVMe, 10 gigabit. I can live with that. I can live with that, especially just starting out. Now, if we end up with you know, multiple editing workstations and multiple this, that, and the other, multiple 10 gig interfaces would make more sense. And be more utilized. We could even use them in like an LACP group if our switch is sophisticated enough. But for now, I'm just thinking, 10 gigabit, that's probably fast enough. As a system architect, you're going to sort of have all the pieces, but you're still going to have to do experiments in order to figure out the best arrangement of those pieces to get the best possible performance. Well, our Google enclosure is really a Dell R710, so it's outfitted with, right now, 96 gigabytes of RAM and 2 6-core X5670 CPUs. I think it's 5670 or 5690. But anyway, two 6-core CPUs, 12 cores, 96 gigs of RAM. Now I've got 12 16 gigabyte DIMMs. It'll run with up to 192 gigs of RAM, and that's what's going to be our final configuration. We've also got 5 of these enclosures. Each one of these enclosures has 24 2 terabyte hard drives with 24 gigabits of serial attached SCSI connectivity to the host. So what I'm going to do is daisy chain 2 enclosures off of 2 controllers so that we've got a balanced, 4-path system. But one option that we have is maybe to only run 1 or 2 enclosures for now and leave the other 2 off until we actually need the storage. With ZFS, we can add those other enclosures as we need storage, so we can keep them off, save money on electricity, and also save wear and tear on the enclosures. That actually works out really well for us. Now we are planning to keep one enclosure, the 5th enclosure, back just for spare parts, spare drives that might die, spare power supplies, spare controllers, whatever we might need. So we are going to have one enclosure that's just completely off. Another option would be that we could actually use 2 servers, like 2 Google type servers, and mirror between them, or we could set up mirrored pools, all this kind of stuff. These are experiments as a system architect that you should do with your real workload to see how it works. ZFS is a hugely complicated file system. It supports multiple independent data sets with different record sizes and things like that. So think about RAID, where the stripe size on RAID is kind of variable depending on like the subcomponent of the RAID that you set up. So if you're running virtual machines on ZFS, virtual machines on ZFS is one of the types of workloads that it performs the most poorly at. But you can, if you really know your workload and you really know your setup, you can tune that ZFS pool to be able to do that. Well, the Google appliance also has 8 2.5-inch bays. So I've got some 500 gig SSDs and some 4 terabyte mechanical hard drives. We could set up a second high performance ZFS pool physically in the Google server and use that for our virtual machine storage and use that for high performance storage, and then use the external enclosures strictly as archive. Now I've added a 400 gig Intel NVMe as a separate log device. Now I'm really only using about 100 gigabytes of that separate log device. I've tweaked the ZFS parameters to keep more stuff in memory for a little bit better streaming performance. Streaming performance in the ZFS vernacular and the FreeBSD vernacular is performance where you've got a stream of data. It's like throughput. It's not IO operations per second. We're dealing with mechanical hard drives. IO operations per second is like 250, and you guys probably know that those Intel NVMe disks can get 400,000, 500,000 IOPS at the peak on those physical devices. So yeah, 250 versus that many IOPS from SSDs makes a huge world of difference. But again, we're not spending thousands of dollars here on just storage. We're trying to thread the needle with this. So what sorts of other fun secondary uses can we come up with this? It's like, well, it seems like a waste to use the entire Google server just as a front end for the storage, just on a relatively slow 10 gig Ethernet connection. What's some other stuff we can do? Well, we can run virtual machines, and we can run something called Docker. Docker is sort of a para-virtualization technology, and it works on Windows, Linux, FreeBSD, you name it. Docker is great because it's one of several different containerization technologies where you have a recipe file, and the recipe file is like, go and get me Linux, go and get me Apache, go and get me PHP, go and get me this, that, and the other. And the virtual machine is built according to that recipe, and then your data is stored independent of that recipe. That makes it really awesome when you need to migrate things, when you need to separate your system from a project that you may be running, but the project requires configuration of Apache or configuration of the database system or configuration of whatever. And so there are lots of Docker files out there for things like email servers and network boot servers and stuff like that. And so 2 big things that we can run on our Google storage appliance that will save us time and reduce our headache. One is a NetBoot workstation. You guys watch a whole bunch of other channels. You guys are probably familiar with this. When it's new board time or when it's time to do whatever, that means somebody's reinstalling Windows like 50 times for 50 different sets of hardware. No. What we want to do is run a Windows virtual machine that has no drivers or anything of any kind. That Windows virtual machine is always on, it's always receiving updates, it's always 100% up to date. When we get new hardware in and we want to do a benchmark or we want to do whatever, we're going to image that instance of Windows to the physical hardware and then install drivers. I think we can automate that with PowerShell scripts. I think we can automate that to the nth degree, honestly, because I do a lot of that kind of stuff. And I think that will make our lives easier and reduce the amount of time it takes for us to have to deal with benchmarking and things like that. It's not ready in this video, but we'll get there, and it probably would make interesting subject matter. So it's like, oh, I need to reinstall Windows. Just boot off the network and then install Windows. Done. Or image Windows to the physical machine and set up the drivers. We might need 1 or 2 virtual machines, maybe one for Intel RST technology and one for AHCI, something like that. But because it's not going to have drivers on it, setting up AMD or NVIDIA drivers from clean will be no problem. And we don't have to wait for the machine to do updates. I mean, you guys have probably noticed that, some people have just squirrely all over the place benchmarks. And when you look into it, it's like, oh, Windows was doing something in the background, or Windows was updating, or Windows was whatever. And you can change your preferences on that, but Windows 10 has been terrible about maintaining your preferences. It's like, I want, these are my preferences. I don't want this. I want this other thing. Windows 10 doesn't really work with that. The other thing is Steam. It really doesn't make sense for us to download GTA 5 50 times a week to be able to do benchmarks. Well, there's a Docker image for Steam cache. Lord knows we got plenty of storage, so we can just carve off 10 or 15 terabytes on this thing and make a 10 or 15 terabyte Steam cache, and then anything in our local Steam cache will come from that system. So I think that will work out really well for us.
Damn, 172 terabytes formatted. I really didn't believe you, but that's amazing.
Never underestimate the power of over 100 hard drives.
The problem is solved. Yeah, pretty snappy too.
Yeah, we can saturate 10 gig Ethernet. I mean, it's FreeNAS at its core, but we're able to run Windows virtual machines or Linux virtual machines or pretty much anything we want. Of course, we've thrown, thousands of dollars of hardware at it to get the good performance, but,
it was worth it. Yeah. So I guess at this point, somebody just needs to go help her move her files onto this.
Yeah, you think we could just slip a note under the door?
They usually just come back out shredded when I do that.
Rock, paper, scissors you for it.
Oh, God, you win those like 90% of the time.
Rock, paper, scissors, lizard, Spock? No,
you win that 100% of the time. All right, traditional. The last time I went in there, I got tetanus.
Well, hopefully your booster shot's still good. I mean, that wasn't that long ago.
Yeah, it's been like 6 months. But if I'm going to do this, I'm going to take a camera.
Okay.
And I'm going to need some kind of light source because she doesn't allow... Oh, great. Great, you've got one.
Should be good.
All right, let's do this, I guess.
I'm going to stay far, far away.
All right, yeah. Right, thanks. Oh my God, it's like 90 degrees in here, but there's no heat. How is she generating heat? Oh, it smells like pumpkin spice and burnt hair. Look at this trash. What's on the wall? God, I wish there was light in here. She stripped out all the copper. I don't know what she did with it. Oh God, stepped on something. I'm not even gonna look. I don't wanna know. Krista, are you here? I've got some good news. Can you just, please don't try to scratch me, please? Oh, what is this? Oh my God, it's not just digital files. This is darker than I ever imagined. Human hair, ooze. What is she doing? These people's lives are in danger. We're gonna have to contact them. I shouldn't be here. But I have to know. Where's all this going? What's it? Oh, God, what was that used for? What is she trying to... Oh no. Oh God, she knows.
So that's our ZFS setup, and it works really well for my needs. So good to have all that storage, just limitless storage for all the things that I need. And, nothing's out of place. Everything's where it belongs. What you doing there?
Nothing.
That's right, you're doing nothing. And we can expand it as much as we want. We can have unlimited storage forever.
Well, you'll have to. You can't just add a single drive with ZFS. You'll have to add multiple drives, preferably a shelf at a time. But we could definitely do that.
You better start adding shelves then.
Yes, ma'am.
You guys should all like, favorite, and subscribe, because if you don't, I'll find out about it.